Hey everyone, this is Eddie here, just talking about mechanical drives and showing you some of the lab setup for that we have here in the Steam Factory at Jackson College. So down here, you can see I've got a couple of different drives set up. There's actually some students that set up the belt drive for their lab, and then I have some gears right here. So the basic idea with all mechanical drives, whether it's a gear, a chain, or a belt, is you want to change speeds and you also want to change torque. Remember that speed is just how fast it's rotating, and torque is the amount of force it's applying. So you can think of speed as I want to go fast on the highway, so I want to go from a big gear to a small gear to create a lot of speed for myself. And if I'm having a tough time opening up a pickle jar, I need a lot of torque. So I'd want to go from like a small gear to a big gear in order to apply more force to the pickle jar to get it open. So it's all about application. It's all about transmitting motor speed to different types of applications and to different locations. So you can see you use a gear drive. They're very hardy, robust. They're made of metal. So they last a very long time. They're very durable, but they can only transfer a very small distance. So if you want to go a long way with a gear drive, you need a bunch of gears that you put into a sequence in order to make that happen. Belt drives, as we see here, are inexpensive, fairly easy to set up, and they work very well, but the belt does wear out, so there is that. But it runs smoothly and fairly quietly. And we also have chain drives, which would be like a metal chain. Works similar to a belt drive, but it's more durable, also more loud. Chain drives can carry more force, but they have their drawbacks as well. So you can see here, if I'm looking at the gears themselves, they interface, and moving the big gear just a small amount causes the small gear to rotate much further around. So one revolution of the big gear is the same as like 4 or 5 revolutions for the small gear. And this is the basic idea here. So because the small gear turns a lot while the big gear turns only once, the small gear is going to be turning faster. Similar with the belt drive, you can see here we have a motor. This would be the driver. So we have a sheave or a pulley that is turning. You can see it rotate. As the motor spins, it's going to pull that belt back and forth. And then we have a driven sheave or a driven pulley, and this is going to be what the rotational force gets applied to. We're transmitting it over the belt, and it's going to then rotate here. So some things to be aware of, just in terms of understanding some basic concepts. The motor is mounted with bolts, and it has an adjustable mount here that it is mounted to, again set up by students, so you can kind of see inside here how this was set up. And over here, these are pillow block bearings. Their goal is just to support this shaft. So we have other shafts in here. These are just made to rotate. So the bearings just kind of hold it in position so it's able to rotate correctly. On the back, we have a load. This is a Prony brake, which is just a load for the motor to be driving to use up the power. And that is it. And then there's, of course, the belt. So the way you tension the belt is you want to make sure that the sheaves are aligned And then you want the belt to have snug tension, but not too snug. So you can measure that with a tension tester. If it's not tight enough, it's not going to correctly transfer force. If it's too tight, it could create extra heat and extra friction and break the belt. Another thing that's important to know is that these belts, because they're using friction to transmit the force, you would not lubricate or grease them. You don't want to have them slide through because that would make them not very effective and create excess heat. You want it to be high friction in order to do its job correctly. With other moving parts, you want to apply greases and lubricants so that they do slide smoothly. And you can see that this is just kind of all bolted together. I'm gonna sort of put down my phone here for a second. And I apologize for the loud noises and the darkness. Just wanted to get the lid on this. So one of the big things to be aware of is that there is a safety concern with these. Oh, and it's not closing because I had the gear stuck on it. So I apologize. That was not what I was hoping would happen, but we got it closed. So we want to have the lid on this thing in order to make sure that we are safe. So when we have moving parts like this, if you have long hair or a baggy sweatshirt or anything that's loose, it can get sucked into it and it can be very dangerous. So over here, we can see this is our basic control panel that's wired up. We have an interlock that makes sure, for safety reasons, that case is on it. And I can turn the power on, and the light comes on. And first, we're going to have a button that's just going to kind of put it in the on mode. So it'll turn a little light up, and it'll be ready to go. We have start and stop push buttons. And then we have constant speed, which is just going to be the max speed of the motor. We can also set it for variable speed, which would give us variable frequency drive to control the speed. I'm going to leave it in constant speed and just show you what happens when I press the start button. So we can see here that the little sheave is driving the big sheave, and the little one is moving at a very high speed. And while it's difficult to tell, the big one is moving at a much lower speed. So because we're going from a small to a large size, the little one will always be faster and the larger one will be slower but have more force. So this belt system would allow us to turn the brake with more twisting force. If we were to reverse the sheaves, it would increase the speed quite a bit. So we'd be turning it with much more speed but less force. And that is the trade-off of what works and doesn't work in a mechanical drive system. So thank you for watching. Hopefully that clears up some information on how mechanical drives work. They're fairly simple. They've been around for quite a long time. Anytime you've seen like old Renaissance or like steampunk things, you see gears everywhere. So they are very old technology, but very useful technology. And understanding how to use bolts and to make sure they're in proper alignment is a really key thing. So hopefully this was a helpful video for you. Thank you for watching.